Hi, it's me again. Welcome back to some more physics study over Easter. I'm going to go over the higher physics waves test, which I punished my long suffering pupils with just before the Easter holidays. I'm just going to go through the answers. Let's have a look at question 1. So a student sets up the following apparatus, okay? We've got a laser, grating, we've got an angle, we've got bright spots, we've got a screen. So before reading the question, what do we know about this? We know that here m equals 0, m equals 1, m equals 2, m equals 3. Okay, that's the first maximum, the second maximum, the third maximum. We also know this angle here is trying to trick us because the angle that we use in any formulas about this is going to be from the 0 line here. So if I can draw a line, that would be super helpful, from the grating to the m equals 0. All right, so 46.4, I don't think so. I'm thinking 23.2. That's what I'm thinking. All right, so a lot of people slipped up here. The angle is 23.2 degrees to the third maximum. All right, so the distance between the lines and the grating is this. So that's d, isn't it? The wavelength of the laser is one of these, right? So it's asking us for lambda. All right, lambda. So what formula do we know with all these things in it? Well, it is, of course, m lambda equals d sine theta. And then you put your numbers in. M is 3. 3 lambda is d, which is 5, times 10 to the minus 6, sine 23.2. You use your calculator and you should get that lambda is 656. 656 times 10 to the minus 9, also known as 656 nanometers, or 6.56 times 10 to the minus 7. And that is your answer. And we have a look in the answer sheet. 6.56, 6.57 times 10 to the minus 7. It must be this one. Yeah, 6.5. It's 6566. Actually, quite a few of you put 46.4 into this, which gave you the wrong answer. But see, the thing with multiple choice questions is just because you have your answer in here does not mean that you're on the right track. Okay, you have to be careful because that's how they get you. So what would it be if you'd done 46.4? Well, let's have a look. I'm not seeing much working on these guys. Right, you're working on the paper, so I know what you're thinking. Oh, there we go. C. So if you put in 46.4, you would have got C, this one. So they know what you're going to do. They know you're going to make a mistake and choose that number, and they put that in there to trip you up. All right, so you need to don't rush things. Don't rush things, guys. Okay. Moving on. 2. The diagram represents 4 possible energy levels of an atom. 4 possible energy levels of an atom, right? So we're thinking electrons can drop like this, and yeah, okay, and also the smaller drops. Electrons can make transitions between the 4 energy levels. Which transition involves the greatest energy change, and which transition produces radiation of the longest wavelength? All right, longest wavelength, energy change, right? Greatest energy change, that's easy. The biggest drop is going to be the greatest energy change, okay? So that's SP. All right. S to P is going to be your greatest energy change. Longest wavelength, they're trying to trick us. Longest wavelength means what? Longest wavelength means low frequency. Okay? Roll and shove, remember? Long wavelength means low frequency. Low frequency means low energy. Okay, so it's saying longest wavelength, but it means low energy. So low energy is the smallest drop. The smallest drop means the shortest gap. So it's not going to be from Q to P. Where's the smallest gap? It's going to be this one, isn't it? In my humble opinion, SR. S to R is the smallest drop. It's going to be the smallest energy transition. So greatest SP to SR, SP to SR, this one is your answer, D. Number 3, the diagram shows the line spectrum from a hot gas. Red end of the spectrum, X, Y, Z. Violet end of the spectrum, okay, that's fine. Lines X, Y, and Z are associated with different electron transitions within an atom of the gas. We know that. Why are they telling us things we already know? That's not fair. Which of the following reasons can account for line Y appearing much brighter than lines X and Z? Well, let's read the 5 choices. So which of the following reasons? So it's only going to be one of these is correct. Light causing line Y has the longest wavelength. No. Red end of the spectrum has the longest wavelength, so that's not correct. B, light causing line Y has the highest frequency. Highest frequency? No, that's violet. That is also wrong. They're mocking us. Light causing line Y originates in the hottest part of the gas. The hottest part of the gas. D, light causing line Y is the result of electrons making a much larger transition. No. Larger transition means more energy. More energy means higher frequency. That would be there. E, light causing line Y is the result of more electrons making that particular transition than either line X or Z. More electrons making that transition. More electrons making that transition. So if more electrons are making that transition, what's going to happen? More photons are being released. More photons are being released. Brighter line. That sounds pretty good to me. Light causing line Y originates in the hottest part of the gas. Well, is this an emission spectrum or an absorption spectrum? It looks like an emission spectrum. So emission spectrum, if it was an absorption spectrum, it would be in the cold part of the gas, wouldn't it? But this is an emission spectrum. Line causing light Y originates in the hottest part of the gas. Does it matter what the temperature of the gas is in this case? I don't think so. I like E. I'm going for E on this one. Okay, more transitions equals more photons. Number 4, the diagram below shows a ray of light from a laser passing from air into crown glass and then into water. Laser. Oh, we give 5 choices, oh dear, and no angles and no normals. But we do have, what do we have? We have the refractive indices of crown glass, 1.5. Crown glass, 1.5. And we also have water, 1.33, and air, 1. Water, 1.33. So we're going to write that on our diagram. Water, 1.33. What is happening here, folks? You have to put the information through your brains and process it. Light travels from air into glass. Well, we've seen this. It bends towards the normal when it enters a denser material, right? denser material. So if it bends towards normal, it's not this one. Okay, so it's not D or E. This one isn't even bending. It's just going straight through, so it's not C. Okay, process of elimination, folks. It's your best friend. So what happens when it goes through into water? So it's going from a more dense material into a less dense material. So it's going to bend away from the normal. It's going to bend away from the normal. And both of these are bending away from the normal. Right? I'll even put a normal in for you because I'm such a nice person. Folks, take a protractor, right? This is my new advice. Take a protractor with you to your exam because it will be useful for various ways, and they might not have them in the area, in the test location. So take your own protractor, right? Okay, so what's going on here, Mr. Young? Why are you tormenting us like this? So that's the angle going, that's angle of incidence. And this is angle of refraction. So I don't have a protractor, but I'm looking at this and I'm seeing that B's angle of refraction is bigger than A. So that means that the difference is bigger between the refractive index than A. But have a look at line B, folks. Line B is parallel to line C, which is the line going straight through it. Now, the only way line B can end up being parallel to line C is if it's going back into air. 1, 1, right? That's the only way the emergent ray can be parallel to the incident ray, is if it's the same index. But it's not. It's the refractive index of water is more than the refractive index of air. So, and also the difference is not as much between 1.5 and 1.33. So that's why it can't be B. So your answer is A. Okay, I hope I've made that clear. All right, number 5. White light from a lamp is viewed using a prism and a grating. A student asked to compare the spectra produced by the two methods, makes the following statements. Okay, let's check these out. 1. The prism produces a spectrum by a refraction. The grating produces a spectrum by interference. Let's just imagine it, folks. So grating is slits, and you've got waves going through the slits, and they are interfering with each other, and they're spreading out the wavelengths, because, as we remember, in diffraction, waves with longer wavelength diffract more. So that's red, will be on the outside. But in refraction, waves with the longer wavelength refract less. So the grating produces a spectrum by interference. Yes, it is a different method. It is a different method of separation of the wavelengths. So this is true. Number 2, the spectrum produced by the prism shows all of the wavelengths of light present in the white light. Sounds good. The spectrum produced by the grating only contains a few specific wavelengths of light. Really? But it's white light we're shining through it. We're not shining a sodium lamp through it. We're not looking at it. We're not looking at burning, what was that stuff called? Remember we did that experiment with lots of salts and stuff, where we set them on fire and they had different colours. We looked at them through spectroscopes. In that case, we saw just a few lines. But this is white light, so this is a big nasty false. That's what 2 is. Number 3, the prism produces a single spectrum. Yes, the grating produces spectra either side of a central white spot. Now, those of you who actually looked through the spectrometer, which I took ages to set up, and point at what did we point it at? We pointed at a little bulb, remember? A little bulb on some batteries, on some books, because that was the only way I could get it to be the same height, and the diffraction grating here. Those of you who actually looked through that, you would have seen multiple spectra on each side. White light in the middle, that's the slit, and then as you move to the side, you would see a spectrum and another spectrum, and another spectrum over here, and another spectrum over here, right? This is true. So true, false, true. Only 1 in 3. 1 in 3 only, the answer is D. Alright, so there, that's it. Those are the multiple choice answers answered. I'm going to do the other ones later. Alright, thanks for watching, bye!